Okay, does anyone have any questions that they want to go over before we get going for today? Okay, we'll go ahead and jump on in then. Today we're going to be talking about, so I guess in summary, the first 2 weeks that was focused on using the command line to take raw data, do the initial processing of that data using open source tools, and submitting large jobs on the supercomputer. And then the last 2 weeks have been focused on Python and kind of using Python as more of like building your own utilities. I think that Python's a very good language for that kind of thing. If you're not using an external library and dealing with large data frames, or need to do some kind of custom manipulation of data, I usually prefer to do that in Python because of the tools available there. But this week and next week, which will be the last week, we're going to talk about R. And a lot of the principles that we talked about during Python are going to be very similar. There'll be minor syntax differences between the languages, but what I want to focus on here is more using statistical packages that are available. R is usually a good environment for more statistical analyses. And then also there's a lot of really good visualization libraries for making really nice presentable plots of your data. And so those are going to be the goals for this week and next week. And so today's going to be mostly just a introduction to R and kind of gaining that grounding of, okay, I've been working in Python, now how do I make this transition? What's different? What's the same? And how do I work with this? And one nice thing about R is being able to use RStudio. So hopefully everyone's downloaded this already. If not, that's fine. You can still download that tonight. So you'll download RStudio, and then it'll also have instructions on how to download the actual R programming language. But once you launch R and you have R downloaded, you're going to have a interface that looks similar to this. And so this is kind of nice because it bundles the command execution, like the terminal and Excel and the help menus and keeping track of the variables all in one window. And so it can be really nice and user-friendly in that regard. And so you can see in this view, so I guess this particular table isn't showing up for whatever reason, but you'll see that here I can look at my different data frames that I've imported. Here I have an R script that I've been writing, and I can write within this box here. Within this window, I can execute actual commands in R. Kind of like when we were using that Python interpreter where you can write a command, execute it, it runs it, and then you write the next command. Here, you'll be able to view all the variables that you've read into memory. So not only will you have a list of the variables, you have their data type. And then if you click on one of the variables that will show up here, you'll be able to actually see what's in the data there, what X is storing, and so forth. And then here you'll see a couple different tabs, but so plots is going to show you any plot that you make. It'll show up in this menu or in this box. and give you options for enlarging the image or saving the image to a file. You'll be able to navigate your file directory and look at the different help menus for different tools. So instead of having to run a Google search, you can say, oh, how do I use DESeek or whatever? And we'll talk more about that either today or tomorrow. And so a lot of the times when you're dealing with data in R, especially if you're using it mostly for interfacing with these pre-existing statistical packages, you're not going to be doing a lot of data manipulation like you would in Python, or like what we did in Python. Mostly what you might be doing is calling pre-existing functions in a library, giving it the appropriate inputs and outputs. But just to help you familiarize yourself with the formatting of how does Python code translate to R code. So just like if you're reading an integer into a value, the technical correct way to set x equal to 1 is to use this caret and dash symbol. I think in more recent versions of R, they allow you to use just an equal sign instead of this caret dash. So I think they built in that flexibility where you can use either and they're fine, but this is the, I guess, correct traditional way of setting a variable equal to a value. And then similarly, just like in Python, if you want to check the type of a variable, you use this type function. If you wanted to force x to be an integer, in Python, we would have written just int parentheses x. Here, the function name is just slightly different. It's as.integer. And again, with a lot of these things, if you're trying to do something in R that maybe you know how to do it in Python, but you don't know how to do it in R, if you just were to run a Google search, like how do I convert a number to an integer in R, then usually the first result or so should be pretty helpful in helping you kind of translate between the two languages. And I think too, especially if you end up working not just in one language, but maybe you decide you want to be working in 2 or 3 different languages for different uses. It's not uncommon to have to, even for simple things. I think when I was making these slides, I had to Google search to remind myself what the exact function was to create an integer in R. So don't be afraid to rely on a Google search for something like that. And I think we mentioned this when we were talking about Python, but so in Python, if you have a number with a decimal, this is called a float or a double. So if you were converting something to a float in Python, you would use Python or float. In R, you would use, instead of as float, you would say as double and then x, and that would convert this float to an integer by rounding it to the closest integer. And vice versa, we can convert a float to an integer using a similar flow here. And then one nice thing is the print function between R and Python are exactly the same. Just print parentheses and then the variable or the string that you want to print out. Strings, again, this is very similar, where the only real difference is in declaring a string is the traditional way of doing this would be to use that caret dash symbol, but again, you can just use an equal sign here. And I think one difference that, so I guess if you wanted to convert something to a string, this is the function here. So that's, again, slightly different than Python. But I guess one more substantial difference between the languages is in Python, let me open up my RStudio real quick to, or I guess I want to be in Python here. Okay. Where did that go? So say in Python, we had a couple variables like hello, y is there. So say we want to print and combine these variables together, then it would be pretty straightforward, where we would just say print x comma y, or print x plus space plus y. So that's a little more straightforward in Python, in my opinion. But say you wanted to combine strings like this, this would essentially translate to the command that I was showing before here, so this paste. So you basically, in a series of commas, you specify all the strings that you want to combine here. And then you specify with a sep argument how you want to separate each of these strings. So in this case, this is going to separate each substring by 3 exclamation marks. If you want to have no space, you just have quotes with no space. If you wanted a space, you'd add a space between the quotes. So I think there are definitely spots where kind of how you're running something in R will vary a little bit more than what you might be used to in Python. But again, there's a lot of help online for figuring out how to use these functions correctly and so forth. Okay. Say we wanted to make a list or an array. So before we would declare that using brackets and then a comma separated list of values. Here, what we're going to do is use this concatenate function, so this C parentheses, and then you list the values to be read into the array, into the variable. One thing of note is in R, if you have mixed data types in the list, so integers and strings, this is going to convert the integers to strings. Whereas I think in Python, the data type would be maintained within the string. So I think that is something I will kind of make sure you're aware of and warn you of, is that in R, it will kind of behind the scenes try to fix things for you. And this is one reason why when I'm writing my own code, I prefer Python, because R will sometimes do kind of funny things like this. But I think that's just kind of to reiterate why it's a good reason to double check your variables and your values and run some tests to make sure everything's functioning correctly. Say we want to make a 2-dimensional array. So instead of a list of lists in Python where it's sets of brackets within brackets, here we're going to run the concatenate function with 2 lists and then specify the dimensions as a list here. And then this is all going to be run within the array function. And then we can access values from within this 2-dimensional array, similarly to how we did in Python. But I think we mentioned this before, in R, instead of, so Python, when you're indexing a list, the first value is actually referenced as 0, whereas the first value in R is actually 1 here. So there's no index 0 in R. You can create a sort of similar to a set. So this isn't exactly the same thing as a set in Python as far as the underlying data structure. But say you wanted to, after you were done manipulating a list, only return a list of the unique values, then you can use this unique function on a list. But unlike in Python, if you were to add an item to the set afterwards, that wouldn't necessarily be compatible here. Whereas if a value was already found in a set in Python, it's going to not add that value because it's already found. Whereas if the value is not there in Python, then it'll add it to that set. If you wanted to use a dictionary in R, so unlike in Python where a dictionary data type is directly accessible within the Python code, you would have to download this hash library, which we'll talk about downloading external libraries in a bit. Then you would initialize that dictionary, that hash, similar to this. And then instead of a single brackets like in Python, we would use double brackets, but then everything else is very similar to how a dictionary would work in Python. So I just kind of want to go over these briefly just so you have a point of reference for how these data types and structures are changing between, and if you decide to use one of these data structures, you have something to reference and start with. Okay, so now let's talk about accessing external or internal libraries. I guess everything will be an external library in R. So say we wanted to download that hash library or this data table library, you go to the tools tab within RStudio, packages, and then search. And we'll talk about this bioinformatics option in a second. But so you can see in that menu, when you have RStudio open, go to this install packages section, and then you can just search for a package name, and then RStudio will handle all the installation for you. So that's another nice feature about RStudio, how it kind of handles all the library downloading for you. So it kind of simplifies things in that regard. So you wanted to install a bioinformatics software package. So a lot of these are available through Bioconductor. So this is kind of the conda of R. And so if you hadn't used Bioconductor before, you could run this command down here where it installs the Bioconductor manager. If you already had that downloaded, then you can run this Bioconductor install command where you specify the package name. And so you can see an example of this being run in RStudio in that terminal. So now that console that I had before in this lower left-hand corner is taking up the full left side of the screen. So I basically, the provided function that they gave is checking if Bioconductor isn't already installed, install it for me. And then here I'm running that install command for dseek. And then it'll shoot out a bunch of text showing that it's installing. Normally, so I'll have this option of, do you want to update all of your packages, some of your packages, or none? So normally you can just say no for this. If there is an issue running the software, then you might want to just reinstall with the all option the next time, but usually you don't have to worry about all or some. You can just do none here. And then, so in Python, if we were importing a library, we would say import library name. So here we're going to be using this library function. And so we just say library, parentheses, and then package name. And you can reference the package name here with quotes or without quotes. R is pretty flexible in how you specify that string. So then sometimes you'll see some text printout saying that it's loading dependencies, or it might not show up with that. But if you were to get an error of something like a dependency not found, then you'd want to go back and reinstall with that all option. And if we had install a package through this previous method here that I showed, within RStudio itself, you would reference and load that library the same way. So let me take a quick break here. Does anyone have any questions so far about what we've talked about? Okay. So like I mentioned, along with resources such as Stack Overflow or BioStars or other forums, the actual documentation that comes with the library, you can access that within RStudio directly. So, and I don't totally understand why this is the case, but normally packages that you installed through RStudio that were available through this option, you would reference that as question mark and then the library name. Whereas other libraries that you download from Bioconductor, like the eSeq, you would use 2 question marks before the package name. A lot of the Bioconductor packages, you can also use this browse vignettes function, and that will launch an HTML version of the documentation in your browser. So you can see here, when I run this for DESeq, it pops up the information here, and then you can scroll through this and look at the different options. I think with this, you can reference it as DESeq2 package or just DESeq2, either one. But this is where you find that those other help accessing methods within Bioconductor. Just below the install information, generally for each package, there's a documentation section where it shows that browse vignettes function, or if you click on this HTML link, then it'll pop open the manual for the software. Okay, so I think we will talk more about DESeq on Wednesday and actually using DESeq, what exactly it's doing and why it's necessary. What I want to do for the rest of today is kind of fill in some more gaps in control flow and logic in R, just so you're aware of how you would do something in R versus Python. So say you wanted to call a function and save output from that function to a variable, you would run it as so here. And if you wanted to run an if-else statement, so the formatting is a little bit different, where we say if, and then the condition that we're evaluating is within parentheses. And then anything that we're going to do if this condition is met we are going to run in these curly brackets. And then if we wanted to use an else if statement, I'm actually just going to skip to that. So I think all of the operators are the same as in Python. But say we want to use an if else statement, so we'd say if else the next condition, curly brackets, and then within those curly brackets, oops, within the curly brackets, then you would say we want to print out the variable. We'd say print y. And then that final statement is just an else with curly brackets. So not too much difference, just a little bit of formatting differences. If we were going to run a for loop, so the formatting similar to the if else statement, where the array that we're running through in the for loop. So here's our array. We say for x and a, and then the condition or what we're going to run in that for loop will be in these curly brackets. So we'd say just print x, which will print each item within this list. And then you can combine for loops and conditionals where you say for x an array, if the number of characters of that word are greater than 2, then print x. So in this case, this would just print hello and world. A while statement. So I think these are the same exact examples that we use in Python, so you can compare if you would like, but you would initialize that counter at the beginning. So I'm going to set y equals to 0, while y is less than 10, print hello, and then add 1 to y during each iteration. And then if y is then 10 or greater, then it will stop that loop and print goodbye. So in this case, this would print out hello 10 times followed by goodbye. But just like in the Python example, if we were only adding 0.5 each time to y, then this is going to print out hello 20 times instead. If we wanted to write a function in R, we would give the function name. So we're basically setting a function equal to the name that we want to reference it later. So then we say, so this function I'm going to make called add1, I'm going to say I'm going to accept 1 input from the user. And then within that function, I'm going to add 1 to x and then return x. And so if we're running a return function here, we need to have what's being returned in parentheses. So then we would run this function just as if we were doing it in Python, where we would say add1, which is the function name. If we put 2 in here, we're going to get 2 out. If we were to say x equals add1, 1, then we would get x equals 2. If we wanted to add 2 items, so I can specify a comma-separated list of inputs, and then maybe we have 1 output, feed the 2 inputs into the function. Multiple outputs is a little bit different. So, and you can mix and match multiple inputs and multiple outputs. But I think in Python, you would just say something like return x comma y. In R, it only allows you to return 1 item. And so if you wanted to return multiple items, you would have to read the 2 variables that you want to export into a list. So then I output that output array. And then I could save this to a variable, and then I would just reference x as outputs index 1, and then y would be outputs index 2. And then if you wanted to, say you had a script, an R script of a series of your own functions that you wanted to have easily accessible and something that you're going to reuse over and over again. So you can do that by, say we wrote this R script. So an R script ends in .r, so this can be lowercase or uppercase. So if we wanted to set our working directory, so kind of the root directory of where RStudio is looking for files at, we can run the set working directory command. So then it's going to assume that everything without more path information is in my desktop. And then say that custom script of functions was on my desktop, then I would just run source custom.r. So this would read that script into memory. And then say I had a script called say hello, and this would just print out hello world. Then I would then be able to access any of those functions that I had written in that script. So as practice, you can, I think this is very similar to one of the exercises we did in Python at the beginning, but just get familiar with the syntax of R, practice some of the things we went over today, and then as well, I would install both the data table library from, so that you'll be able to get directly through RStudio in that install packages window. And then also download DESeq, which we're going to be using on Wednesday. So we'll stop there and let me know if you have any questions. Again, if you have questions from today, feel free to ask those. If you have questions from any of the lessons previously, I'm happy to go over that too.
Jordan.
Yeah.
I have a question. I was trying to download the RNA-seq tools, and I got an error message. It says that packages not found error. The following packages are not available from current channels. And then it listed all the tools that I was trying to download.
Okay.
And is that a common error?
I'm guessing, do you know if you've set your Conda channels to include BioConda and CondaForge?
Oh. Well, I downloaded, I have Miniconda.
Yeah, so within Conda, there's extra channels. So like a lot of the bioinformatics packages, they'll be stored on the BioConda channel, whereas other packages are usually on CondaForge. Let me pull up. Let me open this up real quick. Okay, so I'm gonna activate my class environment, and then actually have to look this up real quick. See if this works. Actually don't know if that's, nope, wrong one. Let's just add I'll add Conda Forge here. Add actually maybe up here. Okay, let me get back to you and I can post this on the Slack channel. So you can check your Conda channels, but if you, I mean, something that you can do is just re-add Conda channels. So what I might do is at first add bioconda, and then I would add conda dash forge. And I will put these on the Slack channel real quick.
Okay.
Yeah.
Okay.
So yeah, I'll see if I can figure out how to list the current ones so you can track, but actually. Okay. Yeah, I'm not exactly sure how to find that. Okay, I think there's a question about going back to a couple of the slides. Let me, last two, okay, go over slide 29 and 30. So in this example, so I create this multitasking function here where it's outputting, so I basically just input X, which I'm potentially modifying. And if it's over 100, it's, Y is going to be a large number. If not, then it's going to be small number. So Y is going to be a string, a new string that's being created. So if I want to return both X and Y from this function, so you would have to install both together as a list or an array. So here I'm basically packaging X and Y into a single variable that's a list. So this is going to be output array. So then I output that single variable. But if I wanted to access those two variables that I output individually, then I need to access them individually from that array of variables that was output from the function. So here I run that function with the one input. I output the outputs from that function into a single variable. But if I wanted to access X out of this list of outputs, I would need to run outputs from index 1 to get just that X variable. If I wanted to get Y, then I need to run outputs 2. Does that answer that question about those particular slides? And then I can go on to that next question too. Okay. I will continue on with the next slide then. Just let me know stop me if you have any questions. So in this last slide, so this is talking about, say we had written this function into a R script file and we saved that as custom.r. So I guess 2 points. If we wanted to, so say custom.r is in our desktop, and we want to just be able to source custom.r like so. we can set the working directory. So basically setting our current directory within R where it's referencing other files from. We can do that running this command. So then I say, take me, this is basically the cd command of R. This is like saying cd tilde desktop. So set working directory tilde desktop. So then I'm basically sitting in the desktop and can directly reference files within desktop. And so then I can run source custom.r, and then that will read that custom.r function that contained this function here. Or in this example, I had a function that was called say hello, didn't take any inputs, and it just printed out hello world. So then if you have a collection of different functions that you want to reuse, you can reference that R script so you can basically recycle those functions over and over again. Does that clarify both those questions, or is there anything else that you'd like me to go over? Are there any other questions that people have?
Thanks, Jordan.
Yeah.
Thank you.
Yeah, no problem.